All right, everyone. Hello and welcome to workshop number 3 of the Solana Super Game Jam. I'm really excited about this one because we're going to be going over a lot of the game development frameworks and tools that are currently available, as well as a segment on Honeycomb and a segment on the new Rush ECS framework from Sonic. So let's get started. So this is the agenda. So the first part will be just an overview of the tools that are currently available. And here we'll be covering Civic, Feed Protocol, GameShift, MagicBlock, Metaplex, and Turbo Computer. And then we'll have a segment on Honeycomb Protocol and then a segment with Sonic, and we'll be covering their new Rush ECS framework. So let's get started. So here's an overview of the current Solana gaming tools. So the first one up is Civic. So what is Civic? So Civic essentially provides tokenized identity to verify individuals. What does that mean? Let's say your game is in a region that requires you to know the age of the players because of specific regions, they have regulations, right? So Civic will verify the location and the age of the users using maybe an ID card, for example. They also have very developer-friendly SDK and APIs, so it makes it really easy to integrate. And recently, they even released their physical ID card, which is really interesting. I would highly encourage everyone to take a look, and it's available at civic.me. So what is Civic doing for the Solana Super Game Jam, and how are they helping us support? So they're offering us 12 months of no SaaS fees. And then also the first 1,000 verifications are completely free for any of those passes. All you have to do is be registered team member, and you'll be eligible. And what does like 1,000 free verifications mean? We'll be going over all the different like levels of the passes that are there, and kind of just going through, what are the different categories. So Civic is trusted by many partners like Solana, Polygon. Also, Realms has an integration with them, which is the DAO governance tool that is created by Solana Labs, as well as they're working closely with Metaplex. One of the interesting partnerships that they have is with a game. It's one of the top games on Solana called Honeyland. And this one is really interesting because they just discussed the statistic at DevCon this year. And what they found in Honeyland was 90% of the revenue for the game itself came from Civic verified users, which is like very interesting, right? And I think this might be because you have an increased quality of users, which is just because there's like less bots that are maybe farming in the game and kind of ruining the game experience, right, for others. So these are all the different Civic passes that are available. There's different tiers of Civic verification, from like uniqueness, which is like a video selfie, to CAPTCHA that we're all familiar with. They also have liveness, and then also the last one is the full ID verification, which we'll go through a little bit more detailed. These are just all the different use cases, gaming and GameFi, of course, but they also cover DeFi, DAOs, RWAs, smart contract development, Web3 wallets. These are just some examples of how it could be kind of integrated in different verticals. So these are all the different Civic Pass types. So the first part is bots and Sybil protection. This is the CAPTCHA Pass, Liveness Pass, and Uniqueness Pass. Then they have the next tier, which is the identity and age verification, and then the last one is you have the ability to issue, revoke, and also modify passes via their REST API. So that's all for Civic. If you want more information or you're interested in adding verification to your game itself and you want to take advantage of this, let us know in the general chat for the Solana Super Game Jam in Discord, and we'll get you connected right away. So welcome to the next part here. So this is Feed Protocol, and we're going to just jump right in. So Feed provides VRF, but what is VRF? VRF stands for Verifiable Random Function, and essentially VRF is a more advanced form of RNG. RNG is this random number generation that happens typically in every game we play for like loot boxes, match pairing, etc. But VRF is now an on-chain version of RNG. And this is important because if you don't have VRF for your like Web3 games, there is a chance that it could be exploited and vulnerabilities can be found. So it's really important to use verifiable random functions when having any RNG on chain. So why on-chain randomness? Well, it ensures that all the results can be like verified by players, and this fosters trust in your game. And then also there's resilience against manipulation, um, and then enhanced player loyalty because everything's transparent, it's on-chain. So Feed Protocol is built for game developers. They have a 400 millisecond response time. It's very easy to integrate. They have templates with Anchor, Unity, and Solana, and then also a lot of flexible use cases for games, specifically like loot boxes, tournament pairings, reward distributions, and even like random quest assignments. So anywhere where you think that you need to have on-chain RNG, it's a great option for you guys to integrate. So they have a one-page guide to make it really easy to work through the docs, and then one-click PDA, and then each participant in the Solana Game Jam gets 1K in free credits. So yeah, go ahead and take a look, and they have examples in their documentations with Anchor, Solana, and Unity. We'll be distributing out these slides, and when you have a copy of them, you can go through and click on all these links, or you can just go to Feed Protocol's Twitter, find their website, or go straight into the documentation itself. Cool. Next up is GameShift. So GameShift is a single interface for game developers to build on Solana pretty fast. So what does GameShift support right now? So they have this embedded wallet, which is really cool. It's an MPC wallet that's available directly in their REST API. They also have an on-ramp and off-ramp so that you can take fiat payments and then cash those out for the players. And then you can manage in-game assets as NFTs and tokens. And then they also have marketplace support. And then again, everything is integrated with their REST API. So you can go ahead, create an account, integrate and test, and then go ahead and launch. Cool. And then if anyone is interested in integrating GameShift, they're also giving API credits. So if you're looking to deploy on mainnet, let us know, and they'll get you hooked up for the game jam itself. And then DevNet is, of course, free to use their service as you need while you're in development. All right, next up is MagicBlock. So what is MagicBlock? It's a high-performance engine for on-chain games and application. So MagicBlock is a decentralized engine that is highly elastic, scales, and accelerates Solana without any fragmentation. This is an OG team that's been around for a long time, a couple of years now, and they've been contributing and maintaining a lot of the core tools in gaming, such as like the Solana Unity SDK. And their engine is really interesting. So it's called an ephemeral rollup. And what it does is it takes the current state, runs it through their engine, and then pushes the state back directly to the L1 without any state fragmentation or composability fragmentation. And then since it's a single node, the block times are like near the speed of light, and then it's very high TPS, which is perfect for gaming. Build unstoppable digital experiences with server-like performance without servers. So the benefit of this is that if you have like a fully on-chain game or on-chain elements without centralized servers, and you want to do this in like a decentralized manner, then you can easily use MagicBlock. And if you're curious about like the benefits of Web 2 versus Web 3, like why should it be done on-chain or decentralized, I would highly recommend take a look at workshop number 1, where we kind of go over the fundamentals and the main benefits. These are all the platforms that are supported by the MagicBlock engine. And then, yeah, pretty much covers all the main ones for building games. And again, MagicBlock Labs is a Unity verified solution partner. They're maintaining the Unity SDK as well for Solana. So these are all the offerings that they have. In the middle there is Bolt, and that's their composability framework for on-chain games, which utilizes also their game engine, the ephemeral rollups. Then they also have on-chain achievements as well. and then also session keys for like auto signing in game. And then what's really interesting is this new tool called Lucid. So Lucid is a blazing fast validator and development toolkit. And what it does is it allows you to run this like MagicBlock validator in a developer mode so that you have some superpowers. What that means is, like, for example, if you want to change state directly on the fly, now you can do this with Lucid without having to go through a bunch of extra work. So that's a really cool one, and I think it's really powerful for fully on-chain games. All right, now let's jump into Metaplex. So Metaplex powers the digital asset economy on Solana. If you ever interacted with a fungible or non-fungible token, more than likely it was done via Metaplex. The impact that they have is enormous. They were extremely pivotal for Solana's success in the last market cycle. They have over 500 million in digital assets created, over 600 million transactions to date, and over 1.2 billion in creator revenue. This is from royalties, mint fees, etc. More than likely, currently Metaplex's programs are doing a few percentage or even probably a large percentage of the total TPS happening right now on the chain from their programs itself. So their programs are available across different network extensions, which is just another word for layer 2. And we have Sonic and Eclipse. So they're deployed not only on the Solana L1, but also on Sonic, which is an L2 on Solana, and then also on Eclipse, which is an L2 on EVM. So Sonic is a gaming-focused network extension, and they're primarily focused on gaming. They're going to be doing a segment here on their new Rush ECS framework that really streamlines blockchain integration, and that'll be happening in the third segment of this workshop. They also have this hypergrid structure, which is great for scaling games with their parallel processing framework, and then they also have a grant program for their gaming partners and ecosystem partners. So Metaplex loves gaming. So what is Bubblegum? Bubblegum is the program that allows you to have compressed NFTs on Solana. And what's great about compressed NFTs is that it allows you to scale on new orders of magnitudes that we were never able to before directly on the L1 itself, or on L2s even now. And they're trusted by some of the great projects like Star Atlas, Photo Finish, and there's tons of use cases like achievements, in-game items, in-game equipment, skins, and pull-ups. Later on, we'll talk about Honeycomb Protocol, but we use the Bubblegum program for all of our digital assets that are utilized in our protocol. Next up, we have hybrid NFTs. So hybrid NFTs are a new novel type of, solution for liquidity. And what it allows you to do is, last market cycle, so I just want to talk really quickly about this. So last market cycle, we had a lot of issues with liquidity in NFTs. A lot of people didn't want to buy them because when the market downtrends, selling NFTs becomes pretty difficult, actually, because there's not as many buyers. What hybrid NFT does is it really solves this liquidity issue because it allows you to have this swap function between the NFT and the token itself. So let's say one NFT is maybe 5,000 bonk, right? So you can take 5,000 bonk tokens and go ahead and swap it to the NFT. This is really interesting because you can set up systems where, okay, what if I pay 15,000 bonk to get a higher tier NFT, meaning like the rarity is higher. And let's say I want to maybe re-roll this NFT. So I want like a different NFT, right? Or maybe I want to try to go for even higher rarity that's in that same bracket. Well, you can re-roll now. And we believe that this will definitely improve in-game economies. The re-rolling mechanism is really cool. It's going to be, I think, the next biggest wave of NFT projects that'll come out. And the use cases in gaming is just perfect because you already have tokens and people love the status of NFTs, right? And having these two kind of together, solving the liquidity issue, I think is a novel approach. And this is one that I'm really excited about. So what is core? Now, Metaplex core, so this is the best way to think about it is think about NFT, but with additional native capabilities. So what is possible with core NFTs? Now, if you want to have like soulbound items, meaning like it's permanently locked to your user, you can do that. Or if you want to have ephemeral items, meaning like temporary items that disappear, right? Like consumables in a game, for example. Now you can do this with core. So one other use case with core NFTs is that you can have on-chain attributes. So like in this, I think this is like RuneScape player with the party hat. So yeah, we could see all of the possible or all the attributes that are kind of locked in. And then let's say you have like this backpack with different slots in them and items inside the backpack, and then the backpack is soulbound. Maybe some of the items are not soulbound. You can do this all easily with core. And everything is powered by DOS API as well. This is just a simple mechanism with core NFTs. So let's say you have this character, he goes and he fights. There's two options. He either wins the fight, levels up, or he gets hurt, right? And then he has to use an item to kind of re-heal himself, right? Let's say he wins the fight, levels up, then maybe he can evolve into the next evolution of that character or NFT. So this is the QR code to go to the Metaplex documentation and website to learn more. Go ahead and scan this. We'll pause here for a second, and then we'll move forward. Cool. So next up is Turbo Computer. Turbo Computer is this lightweight game engine where you can build games as fast as possible. You can write in any programming language. They have an official Rust SDK, and you can also use a lot of modern tools like AI CodeGen to be able to iterate and build really fast. Also, Turbo Computer is a no-code Solana. It has a no-code Solana integration via their Turbo OS, so that's really cool. Also, Turbo guys are some good friends of ours. Known them for a while now, Josiah and Julian. So shout out to you guys. They're great guys. If you ever go into their Discord and ask questions, they'll be right there to help you get set up and yeah, get through any issues you're having. So connect to chain. So they have this async execution environment that lets large numbers of concurrent players stay in sync in real time. There's no gas required, there's no wallet required, and then they have this atomic event system to plug in to Solana L1 or even L2s for settlement. So what's really interesting about Turbo is it's like this first evolution game engine that's built bottom up to natively integrate Solana virtual machine. I think this is massive because since the game engine itself is natively in Rust, it makes it extremely easy for like protocols like Honeycomb to integrate directly into the game engine. What's also really interesting about Turbo is it's extremely lightweight, both on Web 2 and on the Web 3 side. So because it's designed for sprite-based games, it makes like storing assets on chain also extremely cost effective since everything is like pixel based. And this really makes Turbo like the ideal game engine for maybe the potential next genre of gaming itself, which is maybe like this massive multiplayer on-chain games. MMOGs, new term, just made it up on the spot. But yeah, maybe Turbo is the one that uncovers MMOGs, massive multiplayer on-chain games. So really cool. Go ahead, join their Discord server. You can scan this QR code or go to their website, turbo.computer. The documentation is at docs.turbo.computer. So go ahead, take a look, and go join their community and follow them on Twitter. All right, let's jump into the second section of today's workshop. So in this section, we're going to be going over Honeycomb Protocol. For those that don't know, I'm one of the co-founders of Honeycomb. My name is Karthik Makai. I've been developing on Solana since 2021 with our team, and we'll go through a little bit of the background. But yeah, what is Honeycomb Protocol? So we simplify Solana game development. A little bit of background about us. Originally, we were working on the Solana University team, and this was to open up dev faucets all around the world by onboarding the next generation of builders. Very similar to what Superteam is now. And then in 2022 till the end of 2023, we operated a venture studio and we were engineering partners to 50 plus projects on Solana. Around 30 of them were gaming related projects. So we got a lot of insight on some of the issues we found when we were building Web3 games, and also some of the insights from our clients, why some of these games were not sustainable or some of the challenges they had when they went into production. So everything we learned, we compiled together, we aggregated it, and we brought it into Honeycomb Protocol. So Honeycomb is this culmination of everything we learned within the industry. So our goal with Honeycomb is to streamline Web3 integration into game and dApps. So our SDK enables game developers to take advantage of Web3 by providing on-chain game primitives using a generalized state compression to dramatically reduce fees and streamline development with a single client. So Honeycomb is an SDK that provides all these different on-chain game primitives, and we'll be going through these in the later slides. But we're built using this tech called state compression. And what state compression is it enables scalability on the SVM itself. And you might be wondering, like, why is scalability maybe needed, right? Well, on-chain games are expensive. So putting anything on-chain is expensive. It requires some rent, and these add up really fast for games. If you look at this chart here, this is a monthly on-chain fee estimate per active player. So this is the total monthly fees that a player would have to play that we simulated through a bunch of game genres like idle strategy games, FPS, MMORPGs, MOBA, sandboxes, etc. On average, it was between $80 to $160. And now with compression, we pretty much are able to bring that as close to zero as possible. Now, there's two benefits really here. Number one is now it allows accessibility. So anyone in the world can play, games directly on Solana. And number two, if you want to pay for all of your users' on-chain fees, that's completely viable now, right? With Honeycomb, a game studio can subsidize all of the on-chain fees. So that's a very Web 2 experience, but in a Web 3 game. So this is where Honeycomb kind of sits right now in the stack. At the top there, you can see we have wallets, NFT mints, marketplace, on-ramp, and off-ramps. So we don't actually compete there. We have instead reference implementations with all of these different providers so that we allow you to simply choose the tools that you need. Maybe there's some specific advantages, or maybe you have partnerships with different projects, right? So you might have a preference there. We're pretty agnostic. Where we do really sit, though, is next to the game engine. So we connect in directly into the Unity SDK, the Unreal, Godot SDK, etc. We're also looking at MagicBlock engine and integrating with Turbo Computer here soon. So right now we have the Unity SDK that's fully live, and then also we just released the Godot SDK. The Godot SDK is not updated in the docs, but if you do need access to it, let us know. We'll get you into the early access. And then as far as our deployment, so right now we're fully deployed on the Solana L1, and we're actually also deploying a second version on Sonic as well here soon. Cool. So these are the different modules that are currently available on Honeycomb Protocol. So these are those on-chain game primitives that were mentioned earlier. Now there's 4 buckets here of the different modules available. So on the left here, this is where you kind of start your developer journey. We have our player profiles, our shadow signer for auto signing transactions. And then in the middle there, we have our utility layer, so quest, mission, staking, and then our asset hub, like our character manager, resource manager, payment manager, and then finally our auxiliary toolkit, which is like our guild kit. And we'll be going into more depth into all of these, and we'll break this down and explain what each of these mean. So first off, let's start with the Hive control. So this is the master program. This is where you begin your game development journey. We have this thing called the Edge client, and in order to access the Edge client, you use HPL Edge Kit. So HPL stands for Honeycomb Programmable Language, and you use the Edge Kit as a gateway into Honeycomb Protocol. This pretty much streamlines all your compressed transaction creation. It sends low latency transactions because it's deployed directly on our edge client, and then also manages our shadow signer. So we'll go into more of what shadow signer is soon. Next, we have our player profiles. So all of your users' actions, preferences, statistics, they're stored here. It utilizes the Solana decentralized identifier from identity.com. This is like the standard DID on Solana. And then it's fully compressed. So 1 million profiles is around 4 Sol, which is, so that means like one profile is cheaper than the base gas fee, which is like 5 zeros and a 5 Sol. So extremely, extremely cheap to make one on-chain profile. And then next we have Shadow Signer. So this automatically secures signs transactions for players. It works completely with compression, and you can toggle this on off during game development. And yeah, we're internally testing it, but we actually have it available fully on DevNet. We just don't have it on mainnet right now because we're just going a little bit more cautious on what gets migrated. But it's one of the last items, but yeah, fully available currently on DevNet to start integrating and testing with. And then lastly, we have our delegate authority. So this one is actually very interesting. So let's say in your game, in the previous slide here in the middle, we have like these quests, missions, and staking, right? So let's say in your game, you want the player to maybe create a quest, or you want the player to create a staking pool, or you want the player to create specific resources maybe, right? Well, with this delegate authority, now you can actually delegate the authority to external parties to control on-chain programs, to be able to initiate these different on-chain actions on behalf of the owner of the project itself. So this is great for like metaverse, sandbox style games, or maybe you want to have GMs, so game moderators, to be able to do specific items. And yeah, we think this will be really powerful in action. And this was one that, was highly requested when we were building games. Was just, there was a lot of complexity at the time, but we added it into the protocol, and we're really excited to see how it's utilized by game developers. So next one, we're just going to give an example of player profiles. We'll be dropping this link in the chat. So when you have some time, go ahead and click on this link. It's going to take you to the Pooks website, and this is one of the recent projects that went live with our player profiles. And you'll be able to see they have like a leaderboard, and then when you click on one of the individuals' names, you'll be able to go in and see all the achievements that they have, which in their case, they have these on-chain badges. And then they also have Twitter and Discord integrated using OAuth. This is natively available on Honeycomb, and then you can easily share this profile without even having to connect wallet or do anything. So the whole backend is Honeycomb profiles, and then they made the front end and deployed it. So next up is Nectar utilities. So these are game primitives that can be directly integrated for on-chain utility. The first one we have are quests, and there's really 3 types of quests. So the first is a simple mission where you send an NFT on a mission and then you receive a reward. Then we also have advanced missions. So let's say your player needs to be level 5 to be able to do this quest. So with advanced missions, you won't be able to initiate that quest until a specific level has been hit for that player. We also have linked missions. So if you finish mission A, you can unlock mission B, for example, and then unlock mission C. So linking up missions to go in order. And then, of course, we have staking, so in-game idle rewards and yields. And there's tons of customization with this one. It was actually one of our most deployed programs in 2021, 2022, over 30 to 40 times. And each time we added a lot of goodies in there, and it just ended up having an enormous amount of settings. So you can have, different customizations with like age-based, quantity-based multipliers. So based on how many NFTs you have, for how long it's staked, and then you can like combine that with different collections or different traits as well. So the next one is the Asset Hub. So this is the toolkit to manage all in-game assets. Here, there's 3 buckets. So we have the character manager. In the character manager, you can assemble characters to equip skins, manage consumables as mutable NFTs. You also have the ability to bring in Web3 assets outside of Honeycomb. So meaning, let's say you have a core NFT from Metaplex or an X NFT from Backpack. We support all the standards, or maybe a P NFT from Magic Eden Launchpad. All of these assets can be supported within Honeycomb. We bring them into the protocol and we wrap them, and then we have the assets in a compressed state so that it takes advantage of state compression. Also, our character manager is fully interoperable. So meaning, let's say in the resource manager, you initiate like iron ore, and then using the resource manager, you can create like recipe trees. So go from iron ore to an iron bar to an iron sword, and the iron sword can get equipped to the character using the character manager. So everything's fully interoperable in Honeycomb. That's the beauty of it. Our resource manager uses the latest token extensions, Token 2022. That allows you for more advanced options. For example, you maybe want to have permission tokens. So rather than permissionless, where nobody can take them away from you, maybe you need to have permission tokens because you're in a regulated market, for example. Also, in the resource manager, we can wrap tokens. So let's say one of your resources is the Bonk token, right? That's your in-game currency. We completely support external tokens. And then also transfer hooks with token extensions as well. So it allows you to transfer controls. That's what I was explaining about the permission tokens, for example. And then we also have Payment Manager for allowing game devs to configure marketplace actions, manage payments, manage marketplaces, etc. This is an example of the asset hub. Here we were just like creating this unique mint experience where all of the NFT traits were individual skins, and then you purchase all the skins and then you combine them to create your own character. So one of the most interesting parts of Honeycomb is in the auxiliary toolkit section, which is our guild kit. So here you can create a guilder party with membership, leadership, and hierarchy. You can even send NFTs from multiple players on missions to set custom reward distributions. So here we have like 3 categories. So the first one is the guild chat. This is where, the guild kit. And this is where you can form hierarchy with the guild leader, create trait-specific sub-DAOs within the game, share resources from like a mission or a quest or staking resources. And it just allows for co-op gameplay. Then we also will have a guild chat, so you can talk with your guild members with Discord integration and chat moderation. And then finally, guild quests. So let's say you have like this raid, you need to queue up with a bunch of players and then go on a mission or a quest together. And then you can create like custom reward distributions, like using a guild leader. And then we think this will allow for a lot of unique social experiments to be initialized. So this is some examples of the guild kit. These are also our 2 reference implementations. So on the left here, this is Soul Patrol. Soul Patrol is about to be open sourced here very, very soon. We just finished the deployment. So this game, it was one of the first, we dropped 500,000 CNFTs with Drip in the middle of 2023. So the game has 500,000 characters. We just deployed this game on Honeycomb Protocol, and the total cost for 500,000 players was 1.3 Sol to get the game fully deployed using Honeycomb Protocol. We think this is, extraordinary. It's extremely cheap now. You don't have to spend like the enormous amounts of Sol for large player bases. And this whole game will be made fully open source, so you'll be able to fork it, take it, build on top of it, customize it, change out all the assets, etc. So really excited about that. That's going to be released here soon. If you need early access to it, we can add you to the repo as well. And then on the right here, this is Ocean Explorers. This is also going to be a reference implementation. It's a different type of game. Here you can see we're putting together some NFTs to create this crew, and then the crew goes takes their ship and goes on specific missions that it's eligible for. So that game is also going to be open source down the line. That one's a little bit further from being open source, but it will be the next one that gets opened up. So now we're going to be doing a Honeycomb Protocol demo. So I'm going to kick it off to Shoaib, who is our DevRel engineer, and he's going to be going through a walkthrough of the docs as well as do a quick demo. So we'll switch over now.
Hello everyone, and welcome to the Honeycomb Protocol demo. I'm really excited to show you everything that our framework is capable of. We've been developing it for 2 years, and I can't wait to show you what we've been hard at work developing. So we will begin this demo by taking a look at the documentation. Just a brief look, we won't go in too deep, but I just want to tell you guys what Honeycomb can do and why you should use it, right? So uh, when you go to honeycombprotocol.com, you're going to come here, and this is how you come to the docs. I already have them open, right? Um, you can read our about us. I'm just going to cover our core offerings. We have an Edge toolkit that makes it really easy for you to interact with the blockchain. It makes transactions for you. You only need to provide the necessary data. We have Hive control that will make profiles and user accounts and projects for you. Projects are just apps in Honeycomb Protocol. We have Character Manager where you can turn your NFTs into characters. You can update their traits. Maybe you want to your character leveled up and you want his strength to go from 8 to 9, and that you can do that using traits and updating traits. Resource Manager will be used for mostly tokens. If you want to reward certain interactions with tokens, or you want to burn tokens in exchange for certain in-game actions, maybe you want your players to enter a dungeon, and to enter that dungeon, they need to transfer 100 of a token to you, or they need to burn 100 of a token. That's very much possible. Nectar missions, very exciting. It's on-chain missions that your players can do, and when they complete those, they get XP and a bunch of resources, and you determine which resources those will be. And finally, Nectar staking, um, kind of like Nectar missions, except you don't get XP from it right now. But staking basically lets you stake NFTs. We're working on SPL token staking and which will include APY staking, coming very soon, right? In case you guys want to set up your development environment, we have a very nice guide here, right? And we have covered 2 use cases so far. If there's a use case we haven't covered, you can let us know. Uh, hello@honeycombprotocol.com, or join our Discord. The Discord link is right here, and just let the staff know there's a use case we haven't covered, and we'll get right to it. So currently, we're supporting JavaScript and Unity with SDKs coming for Unreal and Godot. So how easy is it to interact with Honeycomb Protocol, right? Um, to initialize your app, right? If you want to initialize your app, all you need to do is do this, right? First, you will provide the name of the project. You can name it anything, like Facebook, in case you're making a social media app. You need to provide us, hey, who the authority is going to be. The authority is the person who will have complete control over that project. Like if you have missions in that project, the authority can make any changes to it. The authority can remove XP from the mission, so players only get resources. Uh, they will have complete authority over everything, like users and profiles, characters, resources, missions, and staking. Payer, who's going to pay for this transaction? And then what kind of achievements do you want in your project? And what kind of custom data fields you want each profile to have? Like, let's say you want each profile to have a counter that says NFT owned, NFTs owned, and every time a person claims an NFT from you, you want to uh, increase this by one, and then every time they burn an NFT, you want to decrease by one. Um, so that's very much possible. And project drivers, right? Very easy. Project drivers are used when neither the user nor the authority's signature is needed, but someone needs to verify. Let's say your user wants to make a change to their profile. They want to set their country, right? They want to set their country to the USA. But you might want to verify that change on the server side before you reflect that in their profile, right? So first of all, you would validate that data however you want, and then you would send this you would use uh, the project driver's address to make that change reflect in the user's profile finally. Um, also, um, we have a I would like to show you the cost comparison of using Honeycomb versus using another framework that would use PDAs to create profiles and users and whatnot, right? What kind of cost savings can you expect, right? So when it comes to creating a profile, right, without compression, you'll be paying around 0.005 sols, but with compression, the cost is so low that it's below even Solana's minimum transaction cost when the network is not congested. This is 4100 lamp ports, right? And as many of you might know, Solana's minimum transaction cost is 5,000 lamp ports. So there's a cost reduction of 1000x here, right? Depends from use case to use case how much of a cost reduction you can expect, but generally it's going to hover around 400x to 1000x to sometimes even 1200x or 1500x, right? Um, so do browse this, right? Um, we also have usage guides, right? Like how can you start using Honeycomb profiles? How do you add a resource and crafting system, right? Because RPG games really rely on a crafting system where you get an iron bar and you want to create an iron sword from it. That's very much possible. What if you need on-chain verification, that you need every user that comes to your app or game to verify that they're over 12, right, or over 16, um, and do a liveness test that they are an actual person, or do a uniqueness test that they are the only user that's on this app, right? If you do those verifications, then that user will not be able to create another account on your platform, right? We have a guide for that. You can integrate TipLink wallet adapter, and what that can do is you can completely forego uh, dealing with any sort of phantom or backpack. You don't have to do those. TipLink usually uses a person's Google account, and when they sign in using their Google account, they can do everything that they usually can on Solana. That's really exciting stuff. Again, if you feel like if you're unsure how to do something, and if you feel like any of these guides could use an update, or we could publish a new guide, let us know on our email or Discord. Um, from this point on, I would like to show you a usage demo, like Honeycomb in action, right? So in order to access this usage demo, all you will have to do is come to the docs, go to usage demos, and the link is right here, start ticket repo, right? And all you have to do is clone this repo. Go to local, copy this link, and all you will need to do is uh, in your terminal git clone, paste this link, it will clone. I already have this repo cloned with GitHub Desktop, so we will get right to it. So the first thing you will do after cloning this repo is you will run the setup script, and it needs to be run in a Linux environment. Even if you're on Windows, you can open Bash and run this script. And all this script does is it checks if you have Solana CLI installed. It installs all of the dependencies that you need for this repo, right? Adds environment variables, which are right here, right? Generates a couple of key pairs, and the purpose of the key pairs is that the admin key pair simulates project authority functionalities, and the user key pair simulates user functionalities like sending a character on a mission. The admin key pair will be used to make changes to the project and create a mission, and you get the idea. So go through that if you're apprehensive about running shell scripts on your PC, which you should be. But yeah, now I'm just going to give you a tiny demo of what Hive Control can do, which let's just run this demo in the background. All you really need to do to run any demos is run yarn test, and if you want to run Hive Control demos, all you really need to do is type Hive, or just characters, or resource, or missions, or staking, right? I'm going to run Hive Control demos because that's where everything starts. You will create you will create a project here and a profiles tree here. So let's let these run in the background, and let's go through project management first. What are these tests doing? So first, it creates a project. Basically, it initializes your app and tells, hey, this is the admin key pair. The key pair right here is going to be the authority of this project. Um, let's just collapse this test. Oh no, sorry. Let's collapse this test. Then it changes the project's driver. If the project's driver is not there to begin with, it just inserts that project driver there. It creates a project delegate authority, and a delegate authority is a really powerful and really exciting feature that I would like to tell you guys more about because it's really powerful. Let's say you're a project's authority, right? Um, and you have complete authority over that project, as the name implies, but you also don't want to manage everything, right? You might have an MMORPG with 500,000 players, right? At that point, you would be too busy dealing with marketing or a lot of other stuff, right? Um, that you don't want to manage every single aspect of your project. No worries, you can just, if you want someone to manage Hive control for you, like manage profiles for you or manage services for you, all you need to do is create a delegate authority and you mention the delegate authority's key pair here. What this does is this user will only be able to manage Hive control services in your project. They won't be able to do anything else. They won't be able to touch missions or create staking pools, withdraw rewards, anything, nothing, right? And you can give them more delegations. You can completely remove delegations. Let's say an employee left. That's a pretty common use case. But yeah, you can modify the delegate authority. You can add permissions. Like now, I gave the person permission to manage profiles as well as services. Um, so that's an option. Badges are timed achievements. Let's say everyone who signs up between January 1st and January 30th, you want to give them a badge. You would indicate the start time and end time here in seconds, Unix epoch time. Um, and everyone who signs up during that time, they would be able to claim this badge and it will be added to their profile. Just in case you want to track who signed up early and reward those players with tokens and XP and whatnot later. You can then update the badge criteria. Let's say you want to extend the end time to February 28th. You can just come here and update the end time, right? In the users test, we are creating a user with a profile, and a question that often comes up is what's the difference between a user and a profile? So a Honeycomb user is universal. By I mean a Honeycomb user can be thought of like a Facebook account. You can use your Facebook account to maybe log into Shopify and create an account there. All you have to do is sign in via Facebook, right? So why are profiles and users separate? So you might want to create a social media app and a racing game, right? Your social media profile will have your posts and comments and likes and dislikes and your friends, right? Whereas the racing game won't have posts. It can have those if you want them to, right? But a racing game will usually have your past races if you've raced with anyone else, or whether you won that race, and your win rate and your achievements, racing achievements. So that's why profiles are separate. Each profile is going to store relevant data for the platform, for the project that you're working on. Then you can update profiles, right? You can add custom data to this. Like let's say I want to add country, and I'm going to add Pakistan, right? Or city and uh, country. You can do that. Um, you want to add wallets. Each Honeycomb user can have multiple wallets, right? And remember that I said you can perform on-chain verifications. So if a user has done on-chain verifications, if you send this flag to true and refetch their profile, refetch their user account, any verification they've done, it will be in an array named Civic, and you'll be able to access whatever verification they've done. You can remove a user's wallet in case a user wants to remove a wallet from his user account. And lastly, you can claim a badge that you're eligible for, right? Provided you claim it within the start and end time of the badge. And as you can see, all of the tests passed. We did a lot of stuff. All of the tests passed within 2.5 minutes. And we did a lot of stuff. We created a project. We made a project driver. We created a delegate authority. We modified the delegate authority. We created a badge criteria, a user, a profile, right? So all of this is lightning fast. And we've been working to make sure it's lightning fast, and your app will even be able to accommodate thousands, hundreds of thousands of users, and even potentially millions of users, right? And so this is really exciting stuff. This is stuff that wasn't possible. This is stuff that very few other people are doing right now, and we are trying to be at the forefront of that. But we're working with every developer, how we can serve them better, how we can add features to Honeycomb to so they can make their next exciting thing. So yeah, that was the Honeycomb demo. I can't wait to see what you guys will make using Honeycomb Protocol, and thank you for joining me today.
Now that we're done with the Honeycomb Protocol demo, we're going to shift over to the last and final segment of this workshop. So the last section is from Sonic SVM, and they'll be showing their new Rush ECS framework. So I'm going to hand it off to Christian now, and he's going to take you through their new toolkit.
Hi guys, my name is Christian Kirapas and I am currently a senior software engineer at Sonic SVM, and I'm mainly working on Rush, our developer tooling, as well as the Sonic runtime. So Sonic is an atomic SVM chain that is built and more focused on enabling sovereign game economies in Solana. And we do this with a couple of things, such as the hypergrid validator network, our customization primitives, our multi-VM interpreter, our atomic interop pipeline, and our ZK rollup solution in the future, which makes up our horizontal scaling ZK rollup framework. Now, going back, Sonic's focus is infrastructure for sovereign game economies on-chain. And currently, we are working on Solana. This often manifests in two types. The first one is execution environments, such as Sonic SVM, and the second one is developer tooling that allows more game developers to create on-chain worlds, on-chain games, and different on-chain experiences on the network. And one of them is Rush, which is Sonic's ECS framework, or the Entity, Component, and Systems framework. Are you familiar with that? If you're not, then it's okay, because I'll walk you through Rush and ECS throughout this entire lecture. But before that, let me share a really, really fascinating story about people. So, once upon a people wanted to create a fully on-chain game, because people realized that fully on-chain games are better because they're an open and multi-authored experience. Open, wherein the world is open to be perceived by all gamers, by anyone, and no one is going to stop you from being immersed in the game world and being able to see what's going on. And multi-authored because anyone can contribute and extend the gaming world. That means it mirrors reality much more than traditional games, because fully on-chain games allows you to have an existence in the digital world, a verifiable, or rather cryptographically verifiable digital presence. All right? So it's more immersive. But people is a game developer. People is not a blockchain developer, and this is where the problem arises. To build a fully on-chain game, to tap into that open and multi-authored experience as a game developer, people realized that he needed to learn blockchain development, because blockchain development is the prerequisite in order for him to have his functions and operations and data on-chain. He needed to know how to build smart contracts or programs on-chain. And because of this, people was crying. People was very sad. People realized that he wants easy, not complicated. People is a game dev. not a blockchain dev, and people is sad, not happy. That's why Sonic created the Rush way, which, by the way, people is really happy about. So what's the Rush way? The Rush way is a way of developing fully on-chain games in autonomous worlds using Sonic's Rush ECS framework as well as Sonic SVM as the baseline execution layer. And we did this because, or we did Rush, and we built Rush because game engines were originally built to reduce the complexity of game development, such that game developers can focus on game design and mechanics. So Rush is built to enable game developers with all levels of blockchain development experience. That means if you don't have blockchain development experience, and if you do have blockchain development experience, Rush is for you. And it enables you to build on-chain games with barely any know-how around blockchain development. Because we want game developers to be able to build fully on-chain games and autonomous worlds without needing to learn blockchain development. Because once again, just like game engines were built in order to abstract away complexity and allow game developers to focus on game mechanics and game design, we want developers to continue focusing on game design and mechanics. Simple. So how do you start with the Rush ECS framework, which is one of our game development or on-chain game development or autonomous world game development entity component system framework? How do you get started? Well, that's easy. It's actually just 3 steps, which the first one is to create a new project using our Rush CLI tool. That means this is where we install the Rush CLI tool, and then this is where we also create a new Rush project. And then number 2, we configure Rush project files. So Rush project files have different roles in how Rush works, which we will be going over later. And then lastly, you just need to deploy, instantiate, and as well as interact. Okay, so you need to deploy, instantiate, and interact. This is where you use Rush provided SDKs to interact with your on-chain program or your on-chain world. So let's get started. First thing is the Rush CLI. You must install the Rush CLI tool by first installing number 1, the Rush toolchain. Okay, because Rush depends on the Rush toolchain, you need to install Rush first, and they have a really good guide on that. And second thing is Solana toolchain. You need to install Solana because you need some of its Solana CLI, mainly just for creating your wallet and configuring your network, and nothing beyond that. And then lastly, you need to install the Rush ECS CLI using Cargo, which is part of the Rush toolchain, the Rush toolchain. And then lastly, you must verify installation by running Rush, and it should show you the version of Rush that you are using or help output of Rush. So now let's start creating a new Rush project with the command rush new and then the name of your on-chain world. So rush new my on-chain game. Well, yes, that's it. That's all you need to create a new Rush project. Simple, right? And that's the core offering of Rush. We want it to be as simple as possible for game developers to create on-chain games without thinking about blockchain development and still be able to create their on-chain worlds. So quick checkpoint. I'm going to pause here a bit. What command do you use to create a new Rush project? So if you're watching this right now, please comment down in our comment section or in our chat or lecture chat or just send us an email at Sonic on what your answer is to this. What command do we use to create a new Rush project? So let's go over the Rush project files. Rush expects 3 files. So the Rush CLI tool expects 3 key files. The first one being the Rush manifest. So the Rush manifest is simply the Rush project file's main configuration file, which is in the TOML or TOML format. And the Rush TOML or the Rush manifest file contains the name of your workspace, the storage that you're using. In this case, you want to store your data for your game on chain on Solana. Okay, you want to store it on Solana. That means Sonic's Solana execution layer. All right. So this part, the repository, it only currently supports Solana, so you don't really have to look for what other values to write here. Just write Solana. And then for the rest, you need to write the storage program address that is deployed on Sonic, the RPC URL you will be using for your game, and then the key pair path that will be used to sign when you're migrating or when you're instantiating your world. So here are some example values for Sonic DevNet. All right. So you can click that at the bottom and see documentation. Now, the second thing that a Rush project looks for is a blueprint folder that contains a gaming blueprint file, which is the world.toml. This is the meat and potatoes of Rush because this defines what exactly would exist in your world and how it will be accessed. And it looks like this. So from the get-go, this is the benefit of Rush, mainly. From the get-go, you can see that we're going to define an on-chain world without you programming anything on-chain. We just need to understand TOML, which TOML is clearly an ubiquitous configuration language that almost every developer understands, and it's easy to understand what it means. For example, without even knowing the inner details of Rush, you would see in this Rush gaming blueprint that we have a world table that has a name, my on-chain world, with a description of my on-chain world description, which, by the way, both name and description has a 32-byte or 32-character length limitation. So it'll error if it's more than that. And now, we have an entities list that lists the name of the entities or the gaming primitives that exist in our on-chain world. And lastly, we have a regions list that lists down the name of the regions of memory or regions or areas in our on-chain world. So in this case, we have base. So we have in our on-chain world, we have an area called base. And it's an area or region in this on-chain world where some of our entities or gaming primitives will exist, such as a player. And then we'll have another table that defines the properties of a gaming primitive, such as a player gaming primitive. In this, we see that a player gaming primitive has a name, which is a string, has an X and Y value, which are all 64-byte floats. All right. Now, for our base, it defines if any entities exist in our region base. So it's called the gaming blueprint, which is in the TOML format. We will be able to use different formats in the future, but currently we want to maximize the familiarity of our users. So we don't want to use overcomplicated domain-specific language or DSL, and we don't want to use things or innovate on things that people don't already know. We want to start from what you already know so we can have a better developer experience as a whole. So in the gaming blueprint, we have 3 tables, as we have discussed later on, surface level, previously. First one is world. Second one is entity, and the third one is a region. So let's go over the world table first in our gaming blueprint. The world table contains the details of your game's on-chain world. Specifically, it states the name of your world, the description of your world with 32 character limit, and the entities list and regions list of your world. For example, my world, as the name, description, my fully on-chain gaming world, entities, player, pig 3, and regions base. That's the world table in your Rush gaming blueprint. Next is the entity table, which the entity table simply contains the names of the entities with their expected properties, which are what we call gaming primitives. All right, this is your on-chain gaming primitives. For example, we have a player. We have a player on-chain gaming primitive that we know on-chain has a name. And we know on-chain has an X position. And we know on-chain has a Y position, with both of which are floats. And with the name being a string. That means in this on-chain world, we expect to be able to create, read, update, and delete player entities. Currently, this pre-release version, Rush only supports 4 data types for on-chain gaming primitives, which are string, F64, I64, and bool, which are bound to change in the future. Now, the next one is the region table. The region table states what region exists on your on-chain game. For example, a region that contains the initial entities and their instantiated properties. As an example, you can see here we have an entity called player that has a name X and Y property. So we have a player gaming primitive. And this player gaming primitive is part or instantiated on the migration of your on-chain world. It is instantiated on the base region. We have one player gaming primitive or player entity named player1 with X and Y values as 0. Okay? So, these are the initial entities that will be loaded into your world once you deploy your world on chain using Rush, which you'll see later. And entity types must match. So, for example, if a player's name must be a string, it has to be a string. If a player's name is a float, it has to be a float. If a player's name is if a player's position, is a float, it has to be a float. So it has to match the definition of your gaming primitive in the entity table. Okay? So, quick checkpoint. What are the 3 project files in a Rush project? Comment down below, send it as an email, or comment it in our current lecture chat. Okay. Lastly, out of the 3, once again, first is the Rush CLI. The second one is we defined our Rush project files. We configured our on-chain game by configuring the Rush project files. And lastly is the Rush SDK. The Rush SDK is the SDK that you will use in order to interact with your on-chain gaming world in your game. Alright? So, for example, at the time of writing, Rush currently have both a Bevy SDK for Bevy game engine and a Web SDK for typical web-based games. And will be more in the coming weeks as we develop Rush beyond the pre-release and alpha stage. So first is you migrate your Rush project on-chain with the Rush CLI tool with Rush deploy. So you go to your Rush project, the root, and then run Rush deploy. And what this does is it migrates your configuration, your world, and the entities you've mentioned you have using your Rush project files on chain. And how do you interact with these entities and components on chain? Well, you use the Rush SDK. Okay. So interact with your on-chain world using the Rush provided SDKs. Cargo currently this is for Bevy. So Cargo add Rush ECS core and Cargo add Rush ECS SDK. So you are able to import the necessary data types and the necessary SDK in order to interact with your on-chain game. So lastly, instantiate and interact. So you can see here in the screen, we instantiated the Bevy SDK with the values that are inside our Rush TOML file. So that's a devnet.sonic.game as our RPC URL, the storage program address, the path to our blueprint, and then the path to our key pair. All right. Okay. Then we get our X value and Y value, and when we fetch it, and then we unwrap the float because we understand from our Rush gaming blueprint that our player X and Y are floats. And then lastly, we update the state, specifically the transforming position, with the X value that we have fetched on chain. So it's that easy. You didn't have to program in any way. You just needed to use your SDK, which is specific for your game engine, and then get the details and information that you have in your Rush manifest, which was the RPC URL, storage program address, and your key pair path. All right? So recap. First, you create a new Rush project using the Rush CLI after installation. And then you configure your Rush project files with the Rush manifest, the Rush gaming blueprint. And then lastly, you use the Rush CLI tool to number one, deploy by running Rush deploy, by instantiating, by importing the SDK, then instantiating the values, and then interacting with your on-chain world by calling the SDK functions. And you can know more about this using our documentation, which is linked on the previous slide. You can see here. Okay. So recap, create your Rush project, configure your Rush project files, and then deploy, instantiate, and interact, which is our 3-step quick start for Rush. So in our alpha or pre-release version of Rush, this is simply how it works. Rush interprets your gaming blueprint, and then Rush gives you access to two things. Rush gives you access to the storage program, so it parses your gaming blueprint and then migrates that and deploys that on the storage program on Solana currently. And then it also gives you SDKs that would allow you to interact with this on-chain program on Solana, which your games will be using. So you're all right. So recap: you have a gaming blueprint that Rush interprets, then Rush creates or migrates your gaming blueprint based on the data you've added to the on-chain storage program on Sonic, and then Rush gives you SDKs that would allow you to interact with this on-chain program with your migrated on-chain world based on your gaming blueprint that your games will use. All right. So what's next for Rush? There's a lot of work that's coming in for Rush around improvements, fixes, more SDKs, open sourcing, a stable release cadence, and some community discussions around Rush and its product roadmap. As well as for version 2, we're going to pursue code generation and lectures and parsers, which will be the pivotal features that allow experienced blockchain developers to modify the behaviors of the on-chain systems that we have set. But it's going to come into the version 2. So that's it. And if you have questions, please do write them in our lecture chat right now. Once again, thank you. My name is Christian Kirapas, and I'm a senior software engineer at Sonic SVM.
Awesome. Thank you, Christian, for that awesome demo of Sonic SVM Rush framework. If anyone needs to contact Christian directly, he'll be in the chat here, so you can DM him. Just want to say thank you for everyone that came today and attended today's workshop. There's this QR code to access all of the resources and links in the Notion document attached there. And then just to go through an agenda recap. So today we did an overview of the current Solana gaming tools from Civic, GameShift, MagicBlock, Metaplex, Turbo, and Feed. And then we went through Honeycomb Protocol. And finally, we ended up with Sonic's new Rush ECS framework. Thank you, everyone, for attending today's workshop, and really looking forward to seeing you all on Thursday when we go through the next session. Bye, everyone.